In this video, we're going to explain what a matched pair experiment looks like. And you'll see we start off with a picture here of two identical twins. And it's funny, I put in a Google search for identical twins, and this is what came up. And as you can see, these are two identical twins who married identical twins. And the reason it works out to explain a matched pair experiment is different from a completely randomized experimental design, which we've looked at in previous videos. A matched pair experiment is exactly what it sounds like. You want to try and match up your subjects into pairs, and the ideal way to do that is if you had twins, okay, and every single subject in your group was a twin. So obviously, most of the time that's not going to happen. You're going to have a group where there's 30 different people, there's 100 different people, there's 2,000 different people. But again, the goal is to try and match up those people into pairs and as similar into groups as similar as possible, right? So what I always think of aside from twins is based on different variables like your age, maybe your gender, maybe your height, your weight, your major, if you're a college student, maybe IQ, all right, genetics, basically any, and this list could go on and on and on, but I want to look at all these variables and then try and match up people again based on these variables. So they're with somebody that is very close to their DNA, to their makeup, okay? So for this example, I'm going to call these guys a group or pair 1, and we're going to call the girls here pair 2, and I'm going to label him A, B, C, and D. This will hopefully make sense in a little bit. All right, so matched pair design. If we wanted to diagram a matched pair experiment, oftentimes it becomes a little overwhelming to diagram it out, and you'll see why in a minute. But it takes on kind of the same nature as a completely randomized experimental design, except you don't start with randomization. In fact, you start off with this process here of figuring out what age is each subject, what gender is each subject, height, weight, and then matching them up. So in step 1, we're going to say we match our subjects into pairs. That's where that's going to be our starting point, okay? And then from there, you could have pair 1, you could have pair 2, and you're going to have, let's say in this case, just for the sake of this experiment, let's say we have 30 subjects, right? So if we had to split them up into pairs, we'd have 15 different such pairs. Now, if I had to, again, put arrows out for each 15 pair, it's going to become a little overwhelming. And again, another reason why you'll see that we don't often diagram when we deal with a matched pair experiment. Okay, for now, I'm going to put this last one in and just say pair 15. Okay, and understand that between pair 2 and pair 15, our pairs, we'll say 13 through 14, okay? But this is kind of like a thought bubble here, and we're going to try and just save some space and really concentrate on pair 1, 2, and then the pair 15 is just in there to show you where the ending point is, okay? So once you match up your subjects into pairs, again, it takes on the same nature as a randomized experimental design. So here, again, think back to an experimental design that's completely random. What do you start with? You start with random assignment. Okay, so once again, we have our subjects into pairs. I'm just going to abbreviate this as RA just to save a little bit of time. Okay, we want to randomly assign our pairs into groups, just like we did with completely randomized experiment. So again, it's going to take on a different look than splitting it up into 15 and 15. If we just have one pair, it's going to be split up into, we'll say, person A and person B. The girls, we can do the same thing. We'll say person C and person D. And if we go all the way to pair 15, we're going to go through the alphabet once, and might look something like this. Person, we'll just say AA for now, and we'll say person AB. Okay, just so each person in that group of 30 has a significant distinct label. Okay, so again, thinking about completely randomized experiment, we start with randomization. We put them into groups, and then we administer the treatment. Now, in this experiment, we really haven't talked about what we're testing. Let's say we were testing the effects of drinking coffee on academic performance. So we're going to say coffee versus, we'll say SAT score. So right before the SAT, one of the twins is going to drink coffee. The other twin is going to drink decaf. Okay, so for person A, let's say they drink the coffee, and for person B, they drink decaf. Our coffee in this case is our treatment. Our decaf is our placebo. Again, we can do coffee and decaf, and again, coffee and decaf. Okay. And then at the very end, we want to compare what our response variable is in this case. In this case, it would be SAT scores. Okay, so we finish up with compare SAT scores. And I'm just going to add one more word locally. Okay, and that word's important for us. It's another way that I think about the difference between a matched pair and a completely randomized experiment. Completely randomized experiment, we take a look at the results from group 1, we take a look at the results from the control group 2, and then we compare them more globally. Okay, with a matched pair, we compare our results locally. So I'm just comparing what happened between A and B. And I do that comparison, I do it 15 times. Okay, so I'm literally going to write the same exact thing. Compare SAT scores locally. Okay, so I'm just comparing what the two girls did between C and D. All right, if person C got a 1220 on her SAT, I'm comparing that only with what person D, her identical twin, got on the SAT. I'm not concerned with comparing her score to one of the gentlemen. That would not be matched pair. Okay, and again, I continue this all the way through. Okay, compare SAT scores locally. Now, you'll notice that I really only did 3 branches of this experimental design. Understand that if this truly were a legitimate diagram, for pairs 13 through 14, which I just highlighted, I should have a branch for each one of those. Obviously, we're going to save some time, but that's how it would look. All right, and I just want to end with one last point of emphasis. I mentioned once you do the matching, it takes on really the same exact nature of a completely randomized design. So I'm just going to highlight this part of the process. If you just zero in on that, random assignment, person A, person B, administer the treatment, which is coffee, administer the control, which is decaf, and then you compare that nature of the experiment. You're just doing it 15 times. Basically you're doing a completely randomized experiment. You're doing it 15 different times. So matched pair, again, very similar. It's just you're doing that one extra step of matching them up before you start the experiment.